From here to the stars. I am your host, Stephen Euin Cobb. Our guest today is Dr. Tracie Prater, a NASA aerospace engineer primarily supporting projects related to 3D printing, materials certification, and manufacturing in space. I'm speaking with Dr. Tracie Prater. There have been several 3D printing facilities on the International Space Station. What are the materials, size limitations, and details in features available with current capabilities?
So we've now tested 3D printing with 3 different experiments, or we call them payloads, on space station. So the first printer that flew was with a company called Maiden Space, and we call that the 3D printing and zero-G technology demonstration mission. And so that printer was a fused filament fabrication system. So if you have a 3D printer in your home or school or your lab space using plastics, it probably uses that process. And so that printer performed 2 sequences of operation. We printed 55 parts total out of ABS plastic. So most of those were test coupons that we bring back to Earth, that we evaluate for properties and compare them with ground manufactured specimens produced by the same printer prior to flight. And so following that first mission, there was a second printer that was developed by Maiden Space, also a polymer printer using the fused filament fabrication process. It's called the Additive manufacturing facility. And that uses ABS, it uses Ultim, which is a higher strength, higher temperature plastic, and high density polyethylene. And so that's actually a commercial facility. NASA is one user of that facility on space station. Maiden Space owns and operates that facility. So we've been using that printer since 2016 to manufacture actual parts for evaluation, and even for use on ISS, although those are plastics, so they're not structural parts. And we're also continuing to study materials and microgravity effects on materials and operation of the printer in a microgravity environment. So to your question on, how big a part can you print? So the second printer has a build volume of 14 centimeters by 10 centimeters and then 10 centimeters in height. So that's kind of your working envelope for building a part. So that process also has really good resolution, right? So if you have a 3D printer at home, you can make small parts with fine features using it. And then the third demonstration of printing that we've done was with the refabricator. And so that was a payload from Tethers Unlimited that's an integrated recycler and 3D printer. So the 3D printer portion of that payload uses Ultim 9085, which is a higher temperature, higher strength plastic. It's a copolymer, a blend of two different plastics.
What are the plans for the future with 3D printing on the International Space Station and other missions? Other materials, larger sizes of parts, better resolution in printed features?
So our major focus right now with in-space manufacturing is developing 3D printing capabilities for metals that we can demonstrate on space station. So right now NASA uses 3D printing of metals on Earth for a lot of our rocket engine development activities, both in-house and then with commercial partners. So we're working on how you mature metal printing processes to space station. There are a lot of challenges to doing that. One is power requirements. We get 2,000 watts of power on space station for a flight experiment. So fitting within that box, and then also just the form factor of space station. Your payload has to fit into a locker, or the largest experiment you could have is kind of a refrigerator size facility called an express rack, so about 16 cubic feet with that. So really just adapting those processes to fit within those constraints, and also the safety constraints of space station too, since it is an environment with crew. So we're working with Maiden Space in one activity, and so they're developing a flight experiment called Vulcan. So that's a welding derived 3D printing process. It's really MIG welding being used to build up material layer by layer. And that's compatible with multiple metal materials that you can get in the form of welding wire. So titanium, stainless steel, aluminum. So with polymers, We're also looking at Regolith polymer feedstock blends. So those are interesting. They incorporate kind of lunar simulants or basalt materials. So someday those type of filaments could enable you to use actually lunar resources for 3D printing. And then we also have a lot of work right now in-house here at NASA Marshall in Huntsville on 3D printing of electronics. And so that's something that we're looking to test out on space station as well.
Okay. What was the original motivation for experiments related to 3D printing on the International Space Station? Is NASA's goal to learn, or was it to learn about 3D printing in space with the goal of improving 3D printing processes on Earth, or the primary utility in quickly printing parts for which the need could not be have been anticipated?
Yeah, so our real motivation was based around logistics for the in-space manufacturing project. So space station is about 200 miles above the Earth, and it's readily accessed with a number of different launch vehicles. But as we move farther out, right, we're more logistically constrained. And an on-demand manufacturing capability, if you have something that's really robust, can really reduce the amount of spares that you need, the amount of launch mass that you have to carry. So as we look farther out, right, your cargo resupply is more limited. There's less space available for storage. Space station is as long as a football field. So for ISS, we up mass and store about 4,000 kilograms of spares each year. So we're looking at 3D printing capabilities as a way to potentially provide spare parts, tools, consumables that you might need, and really just reduce our dependency on Earth for this kind of supply chain. There's also, I always think of in-space manufacturing as a way that you can rapidly respond to unforeseen scenarios, like the kind of Apollo 13 moments that might occur on longer duration missions. So to me, that's a really important aspect of this as well, because even though we've had space station now for 20 years, it's been operating continuously, unforeseen failures and hiccups can still occur with hardware.
That was Dr. Tracie Prater. This has been From Here to the Stars, a video series created by the Interstellar Research Group. The IRG is a non-profit organization dedicated to thoroughly exploring the science and engineering that can eventually open up the reality of interstellar travel. Find us online at irg.space. I have been your host, Stephen Euin Cobb. If you enjoyed this video, please hit the like button, and you can subscribe to our channel for other such videos. On behalf of all of us here at the Interstellar Research Group, I thank you.